What if I told you the same coal that has been burned for over 200 years to power our world can now be converted into a clean industrial gas, a versatile feedstock for the future without even setting it on fire? Sounds impossible? But this technology already exists and it's set to revolutionize the energy sector. It's called coal gasification. Today, coal is no longer just a fuel to be shoveled into a furnace. It has become a sophisticated raw material. It is now the primary source for hydrogen, fertilizers, methanol, synthetic fuels, and even the next generation of energy technologies. Almost all coal ranks can be gasified, but their efficiency, gas yield, and operating conditions differ depending on rank, ash content, moisture, and mineral matter. Not every coal field is suitable for this process. Today, we'll dive deep into this entire process from the perspective of a geologist. Most of India's Gondwana coal formed during the late Carboniferous to Permian period, approximately 320 to 250 million years ago. Dense swamp forests covered vast areas of the Gondwana basins. When these giant plants died, they accumulated in massive waterlogged environments. Because oxygen was limited in these swamps, the organic matter didn't decompose completely. It began to turn into a dark, spongy substance called peat. Layer after layer of sand, silt, and clay continued to bury this plant material. For millions of years, the weight of the earth pressed down. As pressure and temperature increased, water and volatile gases escaped. The concentration of carbon began to rise significantly. Millions of years later, peat slowly transformed into lignite, then lignite into bituminous coal, and finally, in rare cases, into anthracite. Coalification is driven by increasing burial, temperature, pressure, and geological time. It's a journey of enrichment and time. For those of you preparing for any state geologist examination, remember, as rank increases, carbon percentage increases while moisture and volatiles decrease. This is fundamental. Now let's look at why Indian coal is unique. Most of our coal resources are concentrated in the Gondwana basins of eastern and central India. These Gondwana coalfields are roughly 250 to 320 million years old, but they have a specific geological signature that sets them apart. Many Indian Gondwana coals typically contain 30 to 45% ash, although the value varies among coalfields and seams. Unlike high-grade imported coals, the high ash content of Indian Gondwana coal results from the presence of abundant mineral matter introduced during deposition and through subsequent sedimentation. This mineral matter later forms ash during combustion. They remain trapped inside the coal, even after millions of years of burial. This is why Indian coal has traditionally been seen as lower quality. High ash means a lower calorific value and lower efficiency during conventional combustion. But here's the breakthrough. This same high ash coal can still be utilized with incredible efficiency through the process of gasification. So, what exactly is coal gasification? Let's clear up a common misconception. Coal is not being burned in the traditional sense. Instead, coal is reacted with a precisely limited amount of oxygen, or air, and steam at extremely high temperatures, often exceeding 1000 degrees Celsius. In this oxygen-starved environment, complete combustion never occurs. Instead, a chemical reaction produces a combustible gas mixture called syngas. Syngas, or synthesis gas, primarily consists of carbon monoxide and hydrogen with smaller amounts of methane and carbon dioxide. Syngas can be further processed to produce hydrogen, methanol, ammonia, and several industrial chemicals. It's incredibly versatile. Let's break down the chemistry for your exams. The first reaction is partial oxidation. This releases the heat required to drive all the subsequent reactions. Next is the water-gas reaction. Here, carbon reacts with steam to produce carbon monoxide and hydrogen. This reaction absorbs heat. Then we have the water-gas shift reaction. Industries use this specifically to boost their hydrogen production by reacting carbon monoxide with more steam. Finally, methanation can occur, producing methane, the primary component of natural gas. These four reactions are the chemical heart of the plant. Exam tip: always remember the sequence: heat generation first, then gasification, followed by shifting the gas for specific needs, and finally methanation. But what if the coal is too deep? Imagine a seam located 1 kilometer underground where conventional mining is simply too expensive or dangerous. Scientists have developed a way to gasify the coal without ever digging it up. This is called underground coal gasification, or UCG. We pump oxygen and steam down the injection well. The chemical reactions happen right there, inside the Earth's crust, within the coal seam itself. Underground coal gasification eliminates the need for conventional extraction of the coal seam, although drilling of injection and production wells is still required. However, UCG is extremely dependent on geology. The thickness of the coal seam must be consistent, and we must avoid areas with major faults. Permeability and the presence of groundwater are also vital. We cannot risk contaminating our aquifers. This is where the geologist's expertise is paramount. Time for a quick revision. Question 1. Which coal rank contains the maximum percentage of carbon? The answer is anthracite. Question 2. Why does Indian coal have such high ash? It's due to the drift origin and the mineral matter deposited along with the organic material. Question 3. What are the two primary components of syngas? Carbon monoxide and hydrogen. Remember this for your Viva and written exams. Coal has powered our civilization for 2 centuries. But as we move toward a cleaner future, its role must evolve. Gasification allows us to use our vast coal reserves responsibly to produce the hydrogen and chemicals the modern world needs. It is the perfect intersection of geology, chemistry, and energy science. Mastering this topic is essential for any aspiring geologist or engineer. I hope this deep dive helps you in your state geologist examination preparation. Keep studying the Earth, and I'll see you in the next lecture.